Question 5 is an application. So take a second here, see if we can break it down a little bit. So satellite sends a signal to cellular towers A and B in two cities and makes an angle of elevation of 88 degrees with tower A and an angle of 87 degrees with tower B. The satellite is 105 miles from tower A. What is the approximate distance between the two cities? Assume that the two towers are on opposite sides of the satellite. So to do this, we're not going to draw a real pretty diagram, but I'm going to use a dot to kind of represent the satellite in the sky. And then it says town A and town B are on opposite sides. So I'm going to put town A over here and then town B over here. So the question is, what's the approximate distance between the two cities? So if this is town A and this represents tower A located there, this is town B and this is tower B. Basically, what I want to know is the distance between the two towers, which is going to be the distance between the two cities. So this is going to be the unknown. Now, notice how they say there's an angle of elevation of 88 degrees from tower A. So what that means is from the horizontal, if I scroll up or rotate up 88 degrees, that's going to be what's called an angle of elevation. So if I'm a person looking up at this satellite, my angle of elevation to see that satellite is going to be this 88 degrees. Similarly, over at angle B, my angle of elevation is going to be the rotation off the horizontal, looking up to the satellite. So I'm going to have this angle of elevation here. And they say that angle of elevation was 87 degrees. Now, they do say the satellite is 105 miles from tower A. So here's the satellite, and here's tower A. So they're saying this distance over here is 105 miles. So it looks like what we have is a triangle. And a triangle, one of the questions is, would this be a right triangle? If it is, I can use SOHCAHTOA. So if I go 180 minus angle A of 88 minus 87, which is the angle B over there, if you will, that's going to give me this up here of 5 degrees. So this is going to be this 5 degrees. So the question though is, what's the approximate distance between the two cities? So again, they're looking for this distance right here. So if this is angle S, if you will, then I can call this side S, if you will. So what we're picking up on is this is not a right triangle, but does it fit the law of sines? We have an angle opposite side. We have an angle opposite side. So it does look like this is the law of sines. So using the law of sines, we know that the sine of this 5 degrees over its opposite side, which we don't know, is the distance between the two cities is S. But the other side of the proportion, the other ratio we have is this, the sine of 87 over its opposite side, which is the 105. So if we know angle B, then this would represent side B. So notice how we do have a proportion. In our proportion, we want to multiply the diagonals. So we're going to multiply the 105 times the sine of 5 degrees, and then we're going to divide by the remaining trig piece. So the 105, I'll clear this off. Well, we'll just keep on going. So 105, if we multiply that by the sine of 5 degrees, again, my mode is already in degree mode. It knows that's degrees. Get that answer. And then if I divide that by the sine of 87 degrees, that'll tell me how far apart the two towns are. So now it says round to the nearest integer. So would that be 9 miles or 10 miles? Well, that one would say I'm closer to 9. So the answer here would just be then 9 miles. So that does fit the law of sines problem. It's not a right triangle. problem.